Hello. Today I'm going to share you some information about LINSTOR. Does anybody heard about LINSTOR? All right. Does anybody heard about Ceph maybe? Or GlusterFS or some solutions like that? All right. So LINSTOR is one of solution which provides you block storage. You can easily integrate it with this Kubernetes. And this presentation will explain how exactly it works. So we can take a look inside all the entities, how it operates. And so after this talk, you will exactly understand how to work with this and how to fix difficult cases. Few words about myself. I started my Kubernetes experience working for Vedas. This is biggest Czech hosting company. I did a lot of fancy stuff, like we put hundreds of servers into the oil, and we were having Kubernetes and LINSTOR running on top of this. Then I switched working for Pelark. I was developing the Chaos Kubernetes platform, where I also bring same LINSTOR and virtualization based on KubeVirt. And since 2023, I founded a new company. Now we develop open source cloud platform, which provides you managed services like virtual machines. You can run Postgres clusters, Redis, Rabbit, S3 buckets, and all of this. And this storage is actually based on top of Talos Linux, uses KubeVirt, LINSTOR, and a lot of interesting technologies. So if you like this talk, please Google my name. You will find any other talks where I describe how the other parts of this platform is working. So LINSTOR is a storage which we use in Cozy Stack, and let's start the talk itself. Let's start from the industry. Yeah, short disclaimer that my opinion is not LINBIT's opinion. LINBIT is a company who actually developing LINSTOR. Some things might be different. I'm not working for LINBIT. I just like this solution, and I just want to share more information about it. If we're talking from the industry perspective, at the beginning we had just as servers, maybe a few servers. So since time go, the amount of servers were always growing. Then they switched to be rack mount servers. And then we start having more racks. Then we started running virtual machines. So we started divide them by multiple parts and run small virtual machines on them. And all of these were needed storage. Previously, the storage for the virtual machines was usually stored locally or on external storage, which was connected through the iSCSI. But there were needed an opportunity to make this storage highly available. So, talking from the storage perspective, there were some solutions which allows you to do highly available volumes. You can actually connect those storages to the servers, and your virtual machines can smoothly migrate from one node to another. That works actually just fine. That worked just fine for a long time. So if you lose one storage head, the virtual machines also continue working from the another one. And if it comes back, we have replication, which replicates the drives between those storages. Usually, such solutions are provided by NetApp, HP, Dell, IBM, and various hardware storages, right? They use iSCSI or fiber channel to connect those, to deliver those volumes to the servers. But you can also you can consider how can you organize this by your own. So there are such solutions like Ceph, GlusterFS, it's already not developed, but still. LINSTOR, Moose, BGFS, there are a lot of solutions which you can use. For now, it is also MyStore, Longhorn. We have continuous amount of technologies which allows you to create highly available storage, fully defined by storage, by software. They usually provide you opportunity to connect those drives using NFS, iSCSI, or even their own protocol. They can use DPDK and various technologies. So talking about exactly this scheme, you can use DRBD to connect, to make this replication. So you can create few block devices, let's say on storage 1 and storage 2, and enable replication using DRBD. DRBD is default, not default, it's one of the solutions which is already in kernel. It works like RAID 1, but on the network layer, and have some extended features like if you shut down and put server back, it will replicate just changed data. All right. Does anybody heard about DRBD before? All right. Many people didn't like it because previously it was, from my opinion, was kind of unstable. There were a lot of issues, and I will explain you how it was before. So previously, if you want to create such scheme, you took two servers, you put drives into it, then you create some RAID on top of these drives. You can use MDADM or hardware RAID providers. And then you create one big DRBD device which can be replicated. It can work in primary, secondary mode. So on top of this DRBD, you can also create LVM. And then you start cutting this LVM to small drives, which you then export to the virtual machines using iSCSI, let's say. If storage go down, the DRBD device on another node becomes to primary, and some highly available IP allows you to, the virtual machine still consume their storage. If it comes back, it replicates the drives back. So the protocols usually used here are iSCSI or NFS. There were some ideas to use it as a common shared file system. Let's say it could be ext4. But I also saw a lot of people do such stuff like running DRBD in dual primary mode and create some clustered file system on top of it, let's say GFS or CFS. So virtual machines can continuously use both of these storages. Unfortunately, don't do that because nowadays you can get porridge out of your data. You don't really want it. The dual primary mode on DRBD is, for now, the main point for having it is to make live migration more working. And the system, how it works nowadays, it's totally different than I showed you right now. So it's time to stop, and let me show you how is it now. The amount of virtual machines continued to grow. Then Kubernetes appeared. We started running containers inside of the virtual machines. Actually, all of them needed volume. But storage system already can't give you, so you need to have something that will automate you creating of these volumes. So you need some more smart system. You need actually orchestrator for volumes. If you have more servers, we need some system which can place the volumes in them and enable the replication. That's actually LINSTOR is. It allows you to create multiple DRBD volumes. Actually, now it creates DRBD volume for every specific device. So we have now one DRBD volume for everything. We have small DRBD cluster for every persistent volume for any virtual volume for virtual machine created by LINSTOR. It works well with Kubernetes, with various orchestrators, let's say OpenStack and OpenShift, CloudStack, OpenNebula. It has drivers for everything. And let's talk about architecture. We can do some comparison of, if you're aware of how Kubernetes works, so it would be easy to you to understand the LINSTOR primitives. Let's say Kubernetes have storage backend etcd. LINSTOR can also work with etcd, but it also supports various storage backends like MySQL, Postgres, and even Kubernetes custom resources. Kubernetes use API for communicating. So you can communicate with Kubernetes through the API or using kubectl command tool. The same is for LINSTOR. It has a RESTful API, or you can use LINSTOR command tool to communicate with it. Kubernetes has scheduler. So every time when you want to run something, some pod, it need to find the node where to place it. In LINSTOR, you have same entity. It's called autoplacer, so it can decide on which node to place exactly specific drives. Kubernetes also have controller logic, controller manager logic, which actually controls all the things in Kubernetes. In LINSTOR, we have just controller. So Kubernetes exports Prometheus compatible metrics. LINSTOR also does that. And the agent for Kubernetes, which is installed on every node, is called kubelet. For LINSTOR, it's called satellite. In interface, we have some similar. I will not pronounce this word. We have some similar things, yeah. So Kubernetes have pod as minimal entity which describes the workload, and in LINSTOR we have such minimal entity. It's called resource. In Kubernetes, pods are consists of pods. In LINSTOR, resources are consist of volumes. If we want to spawn group of pods, we create deployment in Kubernetes. In LINSTOR, we will create resource definition, the group of DRBD resources. So node is similar in Kubernetes in LINSTOR. In Kubernetes, we can use labels for labeling objects. In LINSTOR, we can use properties. And finally, we have storage class, which defines all the parameters for placing. In LINSTOR, they are mapped to resource groups. So we will use these icons to define those entities for the future presentation. So container is a box, pod is a pod, and a resource such, let's say, group of disks. And resource definition is like jar in which you can put those disks. And resource group is set of parameters, so it will be shown as set of parameters. So how they are different? Some logic of Kubernetes and LINSTOR API is different. Kubernetes has no such things like storage pools, layers, and resources. Let's talk about the storage pools. Let's say we have 6 nodes and we want to place some drives on them. And we can see them in, if we invoke LINSTOR node list, we will see all of these nodes defined in this table. So we have their name, they have IP address. On every node, there is LINSTOR satellite listening for the commands. So before we start placing something, we need to put some drives into the nodes and explain LINSTOR which drives is used to store the data. So first layer we put those drives, then we create LVM or ZFS pool on top of them, and the same we can see in LINSTOR. If we will invoke storage pool list, we will see the list of all storage pools. The interesting stuff here that we have 6 pools and all of them have similar names. That's the main logic of LINSTOR, because they stored on the different nodes, but they can have the same name. We have defined driver here, LVM thin or LVM or ZFS. How can you find it on the node? Free capacity, total capacity, and can it have snapshots or not? Because traditional LVM does not allow you to create snapshots. Actually, it allows, but LINSTOR doesn't allow you to do that because they're very impacting performance. If you use ZFS or LVM thin, they will work fine. And now let's talk about the layers. Layers is something here. So first we have hardware layer where we put the drives, let's say HDD, NVMe, SSD. Then we create a volume group, ZFS or LVM, and higher level we have encryption or deduplication using the same traditional technologies in Linux kernel. And on the top level, we have transport layer, which allows you to deliver the final drive to the workload. And here we can use DRBD or NVMe over fabrics. And the last thing, DRBD resources. So every time when you need to create a volume, let's say you have a Kubernetes and you just created persistent volume claim, it goes to the LINSTOR and creates a resource definition there. And it defines that it needs to create 2 replicas. It just creates 2 resources for DRBD and enables replication between them. It just selects random nodes and places those drives there. And now you can find those devices inside the node as normal block devices. Let's see how it works in CLI. So we can run resource definition list. Here we can see resource name, port. DRBD uses TCP port for communicating, so it can use specific port for communication between the nodes, and resource group. Every resource definition also have volume definition. Since every resource can have volume, resource definition can have volume definition. Volume definition defines the name, volume number, how it will be seen in the kernel. So in kernel, you can actually find it as def DRBD 105, the size of the volume and the state. All right, and then it creates resources, which you can also see in the CLI. You can see it in LINSTOR resource list, specify the resource you want to see, and you'll see the same. You have 2 resources with the same name because they are in different nodes. You can see the state of those devices, and you can also see the volume state. So every resource have a volume. The same command, LINSTOR volume list, we see where is it created, because it can be created in different storage pools. And how it's seen in kernel, exactly the device name. So if you'll come on the node and start using this device, you can actually store the data. It will be automatically replicated to another one. The amount of allocated size, because if you use thin provisioning, it will grow in the amount you're writing. And the state. All right, and now let me explain how this thing is working using 4 different layers. First, if we use Kubernetes PVCs, it can actually communicate with LINSTOR. I want to show you more what is happening under the hood when you created PVC and get provisioned PVC by LINSTOR. The first thing is happening, you can use resource group spawn command. So we have a resource group. Resource group actually defines the parameters for placing. Here we have placement count, how many replicas we need to have placed in our storage system. The storage pool name, where it should be placed, should it be SSD or HDD, and the specific layers which we want to use. Let's say we want to have DRBD replication or we don't want it. We can also use LINSTOR as a system which just cuts off ZFS and LVM, which we actually do in Cozy Stack. And volume numbers, in many cases, this setting is just not used. You always have one volume group number with name 0 with no specific flags. And if you want to create new replicated device, you just do resource group spawn. You specify this configuration and the name for the device and size for this device. So it creates resource definition, and then it creates 3 resources. 2 resources are actually needed for the storing the data, and we have the 3rd one. It is used for the quorum. So it has the state tiebreaker. This resource actually used for having quorum. So it does not have any data, but it can voting. If you want to see how it works under the hood of this command, and we can use another syntax. It's called resource create with autoplace option. So first we will create resource definition, so configuration for our resources. We will assign a resource group for it. And then we will create volume definition for it, which describes that inside of this resource definition, inside of this configuration, we have volumes with this size. And then we can create the volumes using this command, LINSTOR resource create, autoplace 2. And it will create the same devices, 2 for storing and 1 for quorum tiebreaker. You can also even go deeper, and you can operate with resources of LINSTOR manually. So here we will do everything manually. We create resource definition, then we assign it to a resource group, then create volume definition, then create the first resource manually, then create the second one, and it will automatically append the third one. All right. This way, you understand the basics how LINSTOR works, and you know how can you use it in case if you use it with Kubernetes, you can simply debug it. So you can use those commands for removing and recreating the devices. Sometimes it might be really useful. But I expecting the question: what will happen if you have 2 storage replicas and if you run pods on the third one or some fourth node which have this replica. In this case, we can use DRBD diskless mode. Actually, LINSTOR does that automatically. So in case if you create, you can create diskless resource which will have any data, but it will be used for accessing this data, reading and writing into it. This also allows you to run Kubernetes and LINSTOR together. That's actually what we do in Cozy Stack. And now let's talk about the things. How can you interact with this? You have 2 components, LINSTOR satellite and LINSTOR controller. If you're interacting with LINSTOR, you're actually interacting with LINSTOR controller, which sends the commands to LINSTOR satellite, which actually manages the configuration. It creates the devices in LVM or ZFS. It writes DRBD configuration and also runs DRBD commands like DRBD adjust. And now let's go deeper. LINSTOR actually is interface for DRBD commands. Here is DRBD and DRBD setup. DRBD always reads configuration file and uses DRBD setup to configure the kernel, because DRBD works right in Linux kernel. It uses these 2 abstractions to configure it. Let's go deeper. That's a final stuff, but the most interested, how the DRBD replication works inside of the kernel. Let's check what is the configuration file written for the resource. We will see such config file. So here we can see that it has name. It has some options. Here is written on no quorum IO error. That means if it lost quorum, it will refuse all the IO operations. And we have configuration for all of these 3 nodes. So we can draw this scheme that we have 3 nodes: the node 1, node 2, and node 3, which is diskless. And every node in DRBD has its own ID. This is very important stuff. You don't see that when you start working, but if something gets confused in this part, you can get footage out of your data. So usually LINSTOR manages those node IDs automatically, but since we go deeper, we just need to understand that they are existing. We also have definition of, for every node, we have definition which device it will use under the hood. So this one uses LVM devices with name test4. On node 2, since we viewing the config from node 1, we also have some funny placeholder. I don't know actually why LINBIT did that, but I think because it makes no sense to write anything here. It doesn't matter which node, for the node 1. And the latest node has no disk defined. That means that this node is diskless. And they also have minor number. Inside of the node, you can run 3 commands. We will run DRBD status, which will show exactly the status of the devices inside of the node. That's the output you will see. So you can see that we run it on node 1, node 2, and node 3. We can see that every node have understanding how the devices looks like for itself. So it knows the state of this device on this node, and it also has some understanding how it looks for the other nodes. So the node 1 knows that for node 2 it's up to date, and for node 3 it's diskless. In case, let's now see how can we manage connections, how we can actually work and repair it. Because sometimes you can get some issues and you need to know how to debug DRBD. For managing connections, you can use commands like DRBD disconnect and DRBD connect. And if you want to disconnect device from the other node, you will run disconnect and specify resource name. What this node will do, it will just refuse connections from 2 other nodes. If you run DRBD status, you will see that weird state is called standalone. That means that node says, please don't touch me, I don't want to talk with you. The other nodes will have state connecting because they will continue trying to reach out the node 1 because they still have it in their configuration. To recover from this situation, we run DRBD connect, and nodes will see each other again. Very interesting point that you can disconnect just single node. So in this small cluster, you can disconnect from node 1 just the node 3. In this way, only node 3 will be refused. The other node will continue communicating. That's an interesting stuff because it is something unusual. That's not how Ceph works. This is how DRBD works. The same way you can establish connection to the specific node as well. All right. Now let's talk about enabling and disabling the resource. If you run DRBD down for this configuration, this device will actually be removed from the kernel. Inside of the node, you will see that this node have no any DRBD device running. The other nodes will continue trying to connect to it. You can run it up, then it will read the configuration for DRBD and recover from this actually config file. So it will apply all the configuration back to the kernel. That also might be really useful. And now let's talk about using created device. Here are 2 commands, DRBD primary and secondary. You need to understand that DRBD uses this terminology for the reason, because primary means the device responsible for writing. In case of DRBD, even diskless replica can be primary, because it will be responsible to deliver this data to both other nodes. So in case if we do mounting, or if we try using it for QEM, or if we open it in exclusive mode, it will automatically switch to primary mode. That's a similar thing if we will just run DRBD primary command. If we will try to run primary on another node, when we have one node primary running already, we will get an error that multiple primary is not allowed by config. But we can be more smart, and we want to create a split brain situation. So I'll have a chance to explain you how exactly you can fix it. First, we will disconnect the node 1 from the rest of the cluster. Then we will create it primary with a force, but it still will not be working because it will say that this node has no quorum. So DRBD has an internal protection from this, but we are more smart, we can disable quorum. So we will use resource option to disable quorum option, and then we can switch it to primary with force mode. And now we can do also interesting stuff. We can try to connect this node back to the cluster, and let's see what happened. The nodes here will automatically detect split brain situation because they have different state when they opened, and they will start having this standalone state. They will actually refuse the connections to each other. Now you can see that there is split brain situation. You have a split brain. All right. Now let's try to fix it. First, we can move one of the primary mode back to have it into secondary mode. If we will try to connect it in this way, nothing will happen because from one side it will start trying to connect other nodes, but other nodes still refusing the connections from them. They can be recovered in a time. There is some time period for that, but we can go to them and run connect command manually. And now we see a new state, which is called inconsistent. DRBD have two failed states. The first one is inconsistent or outdated. Outdated means that the data here is kind of outdated, but it is still usable. And inconsistent if it's already started replication and if you can't actually use this data as consistent data. To recover this, let's disconnect the node again and connect it with this fancy flag, discard my data. So that exactly means that on the node 1, we want to connect this replica back to the cluster, and we want to get state from the other nodes. In this case, it will start replicating, and in a while, it will come back to up-to-date mode. That's actually it. LINSTOR works very well with Kubernetes. And there are a lot of similar things. So Kubernetes works with container runtime and creates containers. LINSTOR works with block devices and block systems and creates block devices. That's very cool that it can work with well-known technologies like LVM and ZFS, because anytime, even if you have failed control plane, you can get your data back using standard DD command. Both of them are export API. Here are many thanks to my ex-colleagues who helped me to prepare this presentation. And now I'm ready to answer any of your questions. Yes, please.
Does it have a manifest like to define this kind of resources or custom resource definitions? Custom resource or custom. If you want to do it in Kubernetes way, does it have YAML manifest for it?
Unfortunately, LINSTOR is defined their own scheme for defining custom resources, so you can't actually manage it using custom resources they use to store the data. But there is Piraeus operator. It has a few configuration manifests which allows you to define the storage pools and define your node configuration. So you can actually deploy LINSTOR very quickly using official Piraeus operator. In case if you want to create these volumes, you can just use normal Kubernetes abstractions like persistent volumes and persistent volume claims. Even snapshots are working.
So it's hard going in GitOps way, right?
Yeah, it's no. You can go GitOps way. In case if you want to use it with Kubernetes, you can use GitOps because it operates. It actually integrates with a normal Kubernetes way for creating volumes and everything. So you can define your manifests as normal stateful sets or operator resources. It will just provision the volumes. This presentation is more about to give you understanding how actually it works and how to debug it. Because normally you don't go to the CLI interface and trying to fix the problems. But when the problems are come, you don't know what to do. Now you know. Yes, please.
At the beginning, you mentioned there are multiple different solutions like Ceph and other things. Did you try to compare them? What did you see like here could be better than other solutions?
Yes, sorry I didn't provide links to this presentation, but you can try to Google article called LINSTOR versus Ceph versus VitaStore and versus MayaStore. And we spent about months doing research, which one is faster and which one is more reliable. There are some benchmarks. I really like the idea of various solutions. I like Ceph, I like MyStore. I just think that you have to choose the storage depend on your needs. In case if you have heavy loaded operations like virtual machines and databases, LINSTOR and DRBD will be better than Ceph. If you have more reads, it might be better to use Ceph because it is better for the reading, and it already has some things like S3 storage integrated. What we actually do in Cozy Stack, we use LINSTOR as block storage, and we have two different storage classes. One for local volumes provisioning without replication, because the database can replicate itself. Let's say we spawn Postgres cluster. It's always better to depend on application level replication. But we also run virtual machines inside of the Kubernetes. And here we use DRBD for have the data replicated. And also user volumes. They can run their own Kubernetes clusters inside of our Kubernetes. They can provision volumes, and we can be sure that this data can be lost. So we always have this replicated. And both options are served by LINSTOR. And for S3, we run CVDFS on top of these block devices, because if you have block storage, you can run anything you want to on top of it.
What exactly you run?
We use CVDFS. This is open source solution. If you heard about Min.io, LINSTOR, CVDFS is a storage system created thanks to Facebook paper, I guess. It is blob storage, and it also has a S3 interface. Yes, please.
First of all, I want to say great thank you, because that's really priceless information, this hands-on experience with DRBD admin. I think like it's hard to underestimate the value of this experience. But look, you brought here an example of how to solve split brain. Yeah, you have to go, you have to SSH to a node, you have to like run some DRBD admin commands. You have to identify which node should be better for a primary role, right? Because you might also have some doubts there. And then you have to promote it manually or demote the other nodes or run this connection things. And that sounds and looks super not user-friendly. From your experience, like if you have a Kubernetes cluster and you run LINSTOR on that, how often and caused by what would you have these cases when you have to intervene manually and dig into this DRBD admin situation?
That depends on your situation. Let's say DRBD is very difficult for handling various networking problems. So if you have no stable networking, you can face many issues mentioned here. But despite of the fact, actually, if you want to debug Kubernetes, it's always the same. Kubernetes consists of controllers and various custom resources which are managed by those controllers. You need to find proper controllers, you need to read events, and you need to construct the chain for debugging. Unfortunately, for now, there are not so many solutions which can be automatically fixed. I like Ceph because it can do that. In case of LINSTOR, there's still sometimes you need to know how to fix it because it expects that you know that to run manual operations. But that depends on where you run it, how you run it. Sometimes you can have no any issues. Sometimes you need to go deeper to understand how it works to fix it. That's actually one of the way. If you want to go deeper, now you know where to go.
Maybe except network problems. Can you name some other conditions which can cause split brain?
There might be various issues. For example, in one version, I think 9.1.7, we lose the data. there were interesting bug, actually how DRBD works. There were talk from Philip Reisner on tech internals. There is a bitmap where it writes any changed, let's say any block in bitmap explains that some part of the drive is changed, so it can replicate it only this part which was changed. There were some issues with this bitmap, and we get a split brain which wasn't defined in the LINSTOR. We see that just two devices as up to date, and we see the different data. So it was something really painful. We actually lose our production data on it. But since that, it was about 6 or 7 years ago, I didn't face any issues. So sometimes it has issues. It can get deadlock in the kernel. It can actually stuck, but never lose the data. Because in case if you want to store the data, it's the most important thing. You don't want your data to get lost.
That's why it's important to define your primary correct, right? Because you might...
You don't do that. Kubernetes does that automatically. So anytime when you start using this device, it works fully automatically until it breaks, actually. There were also questions. Yeah, please.
Wondering if you can employ this architecture crossing multiple Kubernetes clusters, like one in the left data center and the other in the right data center, and not having a stretched Kubernetes cluster, but really as much as feasible, disconnected, separate system serving as the replication part.
LINSTOR itself is actually an orchestrator. That's one of the points we chose that when we were running 800 nodes cluster, because even if you lose your control plane, you still have access to your data. In LINSTOR, you can connect external nodes to the same ones. I'm not sure if you can connect two Kubernetes cluster into one system. I definitely know that there is opportunity to run LINSTOR externally and have Kubernetes connected to this external cluster. So I think that should be possible. Actually, I'm not sure. Anyway, you have this option in LINSTOR that you can create devices, you can create snapshots, which then will be exported to S3 server automatically. So you can use it for creating backups, and it will send not all the device anytime. It will actually read it and send the data, send delta of this data, of the change it.
So you run a 800 node Kubernetes cluster on top of LINSTOR.
Yeah, I had that experience. You can find use case and VEDAS. It was published on LINBIT website. Yes, please.
How different is it, like you pay cost for Kubernetes backup plans? General for public cloud? What advantage do we have, like if we have like additional storage?
This storage is more likely, if you run your own Kubernetes on premise, it's not just the thing that you need to run Kubernetes. You need to make storage system working there. So enable this opportunity to run persistent volumes. You need to enable services with load balancer. And there are various solutions how you can do this. And LINSTOR is one of the solutions which allows you to get fast block devices for your pods. So it's not this kind of storage which provides you object storage. It's the thing which provides you block devices. And you can then use these block devices for pods and for virtual machines if you run them. Yes, please.
First of all, thank you for the talk. Very interesting, very informative. Quick question: you had the example with discard. Does it discard just the differences, or do you build it from scratch?
It just marks this node. You're asking about if we mark node that discard my data.
Yeah.
you're running this command only on one node, and you specify device. Exactly, you say to this device, hey, you need to join to the cluster and download the state. And then it will download the state, only change its state according to its bitmap.
So just the changes, or it's from scratch? If you have a lot of data, terabytes, so it will start from the beginning. So it's like a new node, or just a different?
If I remember correct, DRBD always syncs the data which is changed. So that might be really useful because you can put your node into maintenance, you can reboot it. But again, normally you don't need to run those operations because all of these things are handled by DRBD automatically.
More discard is very scary. Just throw away. That's why.
Discard my data, that's just a funny name for this command, but it actually discards the data on exactly the node and for a specific resource you specify, just one replica.
Two questions.
Yeah, please.
Does these nodes have to run as part of the, if you're running a Kubernetes cluster, do the nodes have to be part of the cluster, or it can be part of a separate LINSTOR cluster and connects to them?
It can be working in both ways. We really like idea of running LINSTOR inside of the Kubernetes. Actually, what we do in Cozy Stack, we provide a ready box solution which brings you storage, networking, and virtualization based on Kubernetes. And it's also based on Talos Linux. By the way, LINSTOR have interesting term. It's called data locality. That means that you can place the data exactly on the same nodes where you have workload running. And in this way, you don't need to have two hops on the network. You have just one because it writes the data in the same node and have one hop to replicate this data.
So is that the performance advantage you see with using solutions like Ceph or Longhorn?
I would say it's very different. First, DRBD is running in kernel, and it gives you really cool performance impact. The second thing that it works different way. For every volume, you have separated DRBD cluster. In Ceph, you have, let's say, full mesh of your data. In case if you will create Ceph cluster of 100 of nodes, it will be faster because the I/O operations will be spread all around. But usually if you use SSDs and you run them locally, you get almost the same performance of those local SSDs. And that's way more faster than just running Ceph. I hope I explained that correct way.
And we have solutions like OpenEBS and
OpenEBS.
Longhorn also does the same.
They also have a lot of solutions. Longhorn, they had even interesting project CStore. They actually get ZFS code and put it into user space. That was really slow, but really working with snapshots and everything. But after all, they have this project, MyStore. That's their latest one. They use DPDK to replicate the data, and it is still slower than LINSTOR. And it does not support your partial resync. Thank you.